Hey guys, last time we talked about the theory of asymptotic notation. But theory. Let's do some examples of actually finding the running time of functions using big O notation. So for quick reference, this is a chart that describes the different running times that we have, with red being the worst, orange being the middle ground, and progressing down to green, which is the best. Obviously, constant time is best, followed by log n. Then we have linear, n log n squared, and the other ones that we don't want to talk about. So, without much further ado, example number 1, a classic for loop. So if we look at this, our iterator starts at 0, and we're going to iterate until our iterator becomes n. So obviously we say that this for loop is going to run n times, but how much time does the code inside the for loop take to run? Well, it's just a print statement, so we say that it just takes a constant amount of time. So here we can say that our function is going to run in t is equal to big O of n times 1 time, which we rewrite as big O of n. And of course, any for loop like this can be rewritten as a while loop, which would have the same running time, big O of n. Example number 3, a nested for loop. So both of these for loops are the exact same as the one we just talked about. They're each going to execute n times, except for this inner for loop is going to execute n times for every time this outer for loop executes. Once again, we've got a constant amount of time executing in this inner block, so we can say that this function executes in big O of n squared time. Example number 4, another for loop, except instead of adding to the iterator each time, we're multiplying it by 2. And so what we need to know is how many times are we going to multiply I by 2 before we reach n. And for those of you that are savvy with math, might recognize this as something that requires the log function. And for those of you that are not so savvy with math, a log function just helps us figure out how numbers grow and shrink. So in order to figure out how many times we need to multiply I by 2 to get to n, we take log to the base 2, because 2 is what we're multiplying by, log to the base 2 of n. And that, coincidentally, is also our running time, because in here we only have constant time operations. So if we combine this together, we've got the time of our function is equal to big O of log to the base 2 of n. And log to the base 2 is so common in computer science, normally we just omit it and say log of n. On to the next one. In this case, we have another nested for loop, except for this outer loop is similar to the first one we did, so it is going to execute n times, and this inner for loop is going to execute log n times. Once again, this print statement in the loop is going to take a constant amount of time. So if we combine this all together, the time of our function is going to be t is equal to big O of n log n. And this guy only has a constant time operation, so it works out as log n times constant, which is 1, so we've got log n. I'm over explaining, I hope you understand it. On to the next one. So in this case, we have another for loop, except inside the for loop we are calling do something. But what is the running time of this function call? Well, in this case, we've got a for loop, but if we look at it, we are multiplying by 2, which is similar to the other loops that we've done. That equals log n, and I have a typo here, that should be 1. Anyways, this is a print statement, so that's going to take O to the 1. So if we combine this together, do something is going to be equal to big O of log of n. What is the running time of this guy? Well, like we said, this is going to run n times, so this is the run time of this for loop is going to be equal to t is equal to n times big O of log n. But we consolidate that and we just say the time is equal to n big O of n log n. Anyways, those are just some quick examples that I fired off to kind of get you guys thinking about how these algorithms running times work, how to determine the big O notation for them. If this didn't make a ton of sense, it's still moving very fast. Just trust me that as we continue to learn data structures and algorithms, and as we continue to continually talk about it, it will become more clear. Anyways, if you like the video, like and subscribe. If you hate the video, dislike and slander, and have a fantastic day.